part-3 is the most interesting topic here is the descriptive statistics, or the so-called data summary. Here we have 3 things to do. We can clear data after import data files. Basically the descriptive statistics, including find wrong entries, have basic knowledge about the sample and targeted variables in a study, and summarize data. So what we're going to do is we will see we'll start descriptive statistics is basically some sort of analyzing data. So let me move forward with this type of data. Okay. So, okay, so basically when I talk about descriptive statistics, so it explains the data used in these examples, where we'll basically explain descriptive statistics when I talk about the mean, standard deviation, variance. I can also talk in this part about the minimum and maximum values, the so-called kurtosis, skewness, and many other things that you've basically probably have heard about. And I'm going to explain each and every term alone. So I won't be able to move forward with the SPSS session unless you basically know these main things. So let's start with applying these steps on the SPSS. So again, we need to click on Analyze, Report, and Case Summaries. Okay, so starting with the descriptive statistics, let me go on Analyze. See, here is Analyze, and then click on. Okay, so we have basically different versions. Here they mention Analyze Reports. So we have to go and see the reports here. See, Analyze Reports, and then click on Case Summaries. You see the steps? It's Analyze, Reports, and click on Case Summaries. Okay, here we came into this window. So we're basically analyzing or basically going into describing the statistics of these variables. So, okay, so here coming into these statistics. So basically, here we have 2 options. We might go for descriptive statistics, frequency for qualitative variables, or we might go for descriptive statistics, descriptives for quantitative variables. Okay, so it's according to our type of research again. So we need to start with the frequency, for instance, for the qualitative, or descriptive for the quantitative. So let's click on the frequencies, move forward here. We can see transform. Let me just do this. Analyze, reports, or descriptive statistics here. See, we can see frequencies or descriptives. It's according to our types of data. So let's start with, let me go back to the PDF and start with the case summaries. Let me finalize this part before going. So Analyze, Reports, and Case Summaries. So here, let's see the variables. Let me talk about only GDP growth to facilitate things. And here we are creating a case summary for this variable. Again, we are seeing a summary for this variable. So I will click OK. All right, so there you go. Now we came in to see this output window. We came into this summarize part. So what we are doing now is we summarize everything we need to know about this one variable we have chosen. We might have to choose another variable, but for simplicity, I chose only one. So as you can see, the GDP growth annual percentage. N is the number of observation, it's 17. Here we have excluded and included percentages and the total. So basically, this is the case processing summary of the variables of the GDP variable in specific. And here we have the values. See, let me make it more clear. So remember the cases, what I mean by N is that the total number of observation or the total number of summaries of cases. N is the total number of cases or total number of observations. It is from 1 till 17. And these are the values of GDP annual growth. Remember, we sorted them in an ascending value, in an ascending order. So it started from -3 till the highest value. So this is a case summary of only the GDP growth annual. We can also do this summary for all the other variables. Again, I'm gonna minimize this window and go for the descriptive statistics. I'm gonna go for, again, the descriptive statistics, frequency or descriptive. So let's start with frequencies. So why I'm doing these things? Because I'm checking outputs to see if anything is wrong with the variables, check the missing values and physical surveys, if you use paper surveys, for instance, and make sure they are real missing. And sometimes you need to recode string variables into numeric variables. I'm gonna cover this topic, recoding, as well in today's session, the type of what is recoding. Okay, so basically here, let's move into the descriptive statistics and do this order on SPSS. So analyze, descriptive, frequencies. Let's do only for the GDP annual growth. You can either double click on this or you can use this arrow and press OK. All right, and in the output window, we can see from its name, I'm talking about descriptive statistics. So it's describing for me everything I need to know with this variable. So here you can see the frequency. So you can see the frequency, so the number of repetition and the values. So the percent, the valid percentage, and the cumulative percentages. I know these things are a little bit more statistical, but you need to know these things to be able to summarize your variable and see how can we create figures just by giving order. So here we did we created the frequency, and we can also create the using descriptive statistics. We can also create descriptives. See, I'm gonna repeat the same action, descriptive statistics, but not frequency. I'm gonna click on descriptives, okay? Clicking on descriptives, also GDP annual. I'm just remaining on one variable to make things easier. Here we have the descriptives. Descriptive statistics. What do I mean by descriptive? Let me just okay, you can see better now. So when I talk about descriptive statistics, what do I mean by descriptive? I'm trying to just differentiate between this action here, the frequencies, and descriptive statistics. So when I talk about descriptive, I'm describing the statistical records of this variable. For instance, the GDP growth. I have the number of observations, 17. The minimum value is -3. However, the maximum value is 4. And we've proved here. See? Okay, see, the minimum value is -3 and the maximum value is 4 because they're sorted here. Okay, so, and even if you didn't sort the data, but it's better to sort it, even if you didn't sort it, it will have the same effect. So see, this is the minimum value and this is the maximum value. This is the mean and this is the standard deviation. Well, I hope everyone knows what's the mean and what's the standard deviation. The mean is 1.54. Well, let me tell you the mean in simple terms. The mean is the arithmetic, or the mean, or the average. Some books call it the average. It is the arithmetic mean across the observations. What does that mean? It is the mostly widely used measure of central tendency. It is commonly called the average. The mean is basically sensitive to extremely large or extremely small values. So if I'm teaching a course, for instance, I need to calculate the mean of the grades of my students. So I add all the grades and divide them by their number. So if I have, let's say, 20 students or 30 students in my class, I add their grades and divide them by 30. So I will be able to calculate the mean or the average. But however, it is highly sensitive to large values or small values. I mean, if I have a grade of 0, let's say, the mean will be affected by the 0. If I have a grade of 20 over 20, the mean will also affected by these large or small values. So here, the mean is 1.54. So it is the average of the numbers. You can see here, it's 1.54. And if you can see the values here, you can see that 1.54 is basically the middle of these values. Whenever I add them and I divide them, no need to do it manually to add the values and divide them by the number, no, because SPSS will do all of these things on behalf of you. But I'm trying to explain the actual meaning of the mean. So this is the mean. This is the value. You definitely need to know the mean of your data, regardless of what type of data, regardless if it is economic data, business data, healthcare, education, hospital, any type of data, you need to know the mean of your data. Coming into the standard deviation, the standard deviation is also an important variable to know here. You're going to ask me, what is the standard deviation? It is the square root of the variance. It measures the spread of a set of observation. It's from its name, standard deviation. So I'm seeing how spread or how much the data is deviated. So the standard deviation, it measures the spread of a set of observations. So the larger the standard deviation, by the way, is the more spread out the observations are. So high number of standard deviation, meaning that the observations are more spreaded. So here the standard deviation is 1.65. It's not large. So this means that the value is not largely spread. And since I defined the standard deviation, I said it is the square root of variance, you definitely need to know what does the variance mean. So when I talk about the variance, it is a measure of variability. It is the sum of the squared distances of data value from the mean divided by the variance divisor. So the corrected standard, the corrected SS, so it is the sum of the square distances of data value from the mean. So basically, we don't generally use variance as an index of spread because it is in squared units. That's why we use standard deviation. Okay, but we need to, whenever we're defining standard deviation, we need to define what is variance. So again, this is what SPSS shows us. It shows us both frequency and descriptive. So here is the table that shows the descriptive statistics of our only, here we're just talking about GDP growth, by the way. We can do the same thing, the same analysis for all the other variables. So we can do the same analysis for the female unemployment and the same analysis for the male unemployment. So let's go back into our PDF. So here we did both frequencies and descriptives. And let's go and move forward here into the creating a report summary in rows. What does that mean? I'm trying now to select variables I want to summarize and move them to data columns variables. What does that mean? Let's follow the steps to see the output window. What does it show us? So here we have to click Analyze, Reports, and Report Summary in rows. Let's go to the SPSS, Analyze, Reports, and we previously did the case summary. Here, let's dive into more details and click Report Summaries in rows. Okay, we'll see this window, and let's follow the steps here so that I can be moving step by step. So we clicked on the report summary, and then we transform the data. Here they transformed all the variables, and then we clicked summary and press continue and okay. And then we choose the things we need to summarize. Let's go and do this on SPSS. So again, we clicked on analyze, reports, and report summaries in rows. So let's just start to do basically on further variables. So let's start to escalate our session into many other variables. So I'm going to add GDP, unemployment female, and unemployment male. Okay, so let's dive and see more summarizing results of our variables, and then click summary. And now let's choose what should our report include. You want to include the mean, the minimum value, the maximum value, the number of cases or observations, the standard deviation, the kurtosis, the variance, or the skewness. And let me choose them all, and I will explain the kurtosis for you and the skewness when they are created in the output session, because I've already explained the variance, the standard deviation, and the mean. So I'm going to choose the sum of values, mean, minimum and maximum, number of cases, which was 17, and standard deviation, kurtosis, variance, and skewness. You need to see all of this data, by the way, so I'm going to explain it now when they are created, and I'm going to press continue. Okay, fine. I'm trying not to make steps in a hurry. I'm just moving step by step, and then I'm going to press continue and press OK. All right, and here's the output report. You can see previously here we worked for descriptive statistics, and here we came into our report. See, the report is classified as columns and rows. Previously, we were working on just the GDP growth. Here, we introduced other variables. I'm just trying to make things to try to think outside the box, because our research always include more than one variable. So let's start to escalate into a little bit harder level. So here, GDP growth, annual, unemployment rate of females, and percentage of male unemployment. So again, we have chosen to have these values. You can choose not to include minimum or maximum in your study. So remember, the minimum value of our GDP growth was -3, the maximum was 4, if you can just start remembering the numbers. You might choose not to have all of these. You might choose only to have mean and standard deviation, for instance. It's up to you. The thing is, you give order, and the SPSS gives you the reports, the statistics, the graphs, and everything else. I've chosen everything because it's interesting to know all these data. So here we have the variables, and here we have the things we need to know. We have chosen to know the mean of our GDP growth, annual, basically the minimum, the maximum, and etc. Okay. Basically here we understand the mean, the minimum, the maximum, and is the number of observations, standard deviation we know. Let's explain the kurtosis. So what's kurtosis here? What do I mean by kurtosis? When I talk about kurtosis is a measure of the heaviness of the tails of a distribution. You know, the tail of distribution, it's when I talk about two-tailed and one-tailed distribution. So it is basically a normal distribution has 0 kurtosis. Extremely non-normal distributions may have highly positive or negative kurtosis values, while nearly normal distribution will have kurtosis close to 0. So here, kurtosis is 2.17. That means that it's not basically a normal distribution, because normal distribution has 0 kurtosis. So you definitely need to understand the results provided to you by SPSS. It's not about just data. No, it's about you need to understand, analyze, and interpret what does each and every data or number mean in relevance to your report. So kurtosis is positive if the tails are heavier than for a normal distribution, and the negative if the tails are lighter than for a normal distribution. So if I want to talk about the skewness as well, here we have a negative skewness. Does that mean? I'm talking about only the growth, remember, not only other values. Here we have positive values. So the skewness, basically, it's a measure of from its name, it measures the degree and direction of asymmetry. A symmetric distribution, such as the normal distribution, has a skewness of 0, and a distribution that is skewed to the left, example, when the mean is less than the median, for instance, it has a negative skewness. So it's skewness, the degree of direction or of asymmetry. So it's easy to understand. So these are the values: skewness, variance, kurtosis. You might choose either all of them or one or two of them for your data. So here it's where you tick on these values and then create the documents needed. Here, as you can see, here we included all of these. Let me make it a little bit more bigger. So here we included all the variables again, and here is the values you have chosen. So you analyze the report basically based on these points. So first of all, let me see, you're probably asking, okay, so why do I need this lot of information? Why do I need to see all of these numbers, figures on my SPSS output? Why? Because you need to see, you need to evaluate the data. What does that mean? You need to evaluate the summary based on these 3 points. First of all, the measures of location and dispersion. When I talk about location and dispersion, I mean 3 things. I mean mean, measures of location, mean, median, and mode. So I have to explain these 3 things: mean, median, and mode when I talk about the measures of dispersion. So basically, when I talk about, I've explained the mean, let me explain the median. The median is, the median basically, from its name, it splits the distribution such that half of all values are above this value and half are below. So it's the median. Okay, so basically when you calculate the median, then it is half of the values are above and half of the values are below. This is the median. So basically, we also have the mode. And basically, when I talk about these values, you need to know the location. So you probably, all of you understood what is the mode. So the mean, median, and mode are basically the measures of location and dispersion. Measures of location, exactly. And when I talk about dispersion, dispersion is the way of spreading the data. So I talk about the range, and the range, from its name, it's the maximum minus minimum. So if I remember, the values were, the maximum value was 4 in a graph, a GDP graph, and the minimum was a 3 minus a 3. So the range here, if I told you calculate the range, it's the maximum minus minimum. So it's basically 4 minus a 3. Okay. So the variance and the standard deviation as well are the spread from the mean. You can see spread from the mean, the highest value, the highest the value, the more the spread. The highest the value, the more the spread. So basically, when I talk about measures of location, there are only 3: mean, median, mode. However, measures of dispersion, the word dispersion can be replaced by the word spread. The measures of spread of the data, they are the range, the variance, and the standard deviation. Okay, I hope this is clear for now. And coming into the number of variables and observations. Here I gave you an example to understand what do I mean by the number of variables and observations. So for the number of observations, we count the IDs or the years. So these are the number of observations. We already did this in our SPSS. You can see, let me show you the number of observations here. See, these years are the N, the big N, you can see in our summary report, the big N, or the number of observations, or the number of cases. Okay, and these are, and for the number of observations, we count the IDs or years. Here you go. And for the number of variables, we count the years. So the variables, which are the GDP, the unemployment rate for females, the unemployment rate for males, etc. Okay, so in our example here, we have two variables compared per year, GDP and unemployment. For instance, just for example. Okay, so I'm trying again to analyze the report summary we created here. This report summary we created, what does this one, what does each and every value and include, or what does it mean, or why do I need it? So we first understood the measures of location, mean, median, mode, measures of dispersion, range, variance, standard deviation, and basically here we see the number of variables and observations. Okay, so coming into a very, very interesting topic in specifying the type of our data. Basically, in statistics, we have two types of data. In every research, by the way, not only economics or from a business perspective, every research has two types of data. First, it is cross-sectional, and the second one is time series. So when I talk about time series, from its name, it is comparing years to each other. So when my data include, let's say, the unemployment rate in India, for example, the unemployment rate for India starting year 2000 till 2022. This is a time series data, because I'm comparing the evolution of this variable I'm studying, the unemployment rate in India, since year 2000 till 2022. So this is a time series data because I'm covering the data from a time perspective. Okay. However, when I talk about cross-sectional data, I'm comparing individual. So I'm comparing individual examples. So let's say I'm doing, for instance, not just comparing the years, I'm comparing, let's say, several variables to each other. So that's why we call it cross-sectional. I'm comparing individual. I'm comparing each and every variable to the other. So that's why it is called the cross-sectional. It's not across time. It's not across time. So here I also explained skewness, and I gave you a very good example about skewness. You can see that when the value is SQ greater than 0, it is positively skewed. SQ0, no skewness or symmetric. SQ less than 0, it is negatively skewed. See, let's go to see the output. See the skewness here. Where's the skewness? Here, the skewness. Here is negative in the GDP growth. In the unemployment for female, it is 0.96 positive. In the unemployment for males, it is 1.23, also positive, but a higher number. So when the skewness again is positive here, and here we have 2 positive and 1 negative. We don't have 0 skewness. So again, when it is positive, it is positively skewed. 0, I mean no skewness, and negatively, it is SQ less than 0. When I talk about kurtosis as well, we measure the peakedness again. So it might be peaked, not peaked, or highly peaked. So it might be very, very, very highly peaked if it is positive skewness. It might be not peaked at all, or I can call it another name. It is normal distribution when K is 0. And it might be less peaked when K is negative. Let's go see the results here. The peakedness, the kurtosis, 2.17, it is high relative to others. See, so it's highly peaked. 0.31, it is also positive, but it is more closer into 0. So it's not normal distribution, but approximately close to the normal distribution, approximately, because it's not 0. And 1.02 is a little bit peaked. So peaked, close to normal, close, and here it is highly peaked according to the kurtosis variable. See, this is very, very, very important, by the way, because it dives into my data, into deep analysis. That's what do I need SPSS for. SPSS helps me to dive deeply into my analysis of my data research. Part 4, well, this is interesting. This is, for me, this is the most interesting part of SPSS because I like to read graphical presentations. I feel I'm passionate about reading graphs because they're interesting, they're not boring, they're easy to understand, and they are well interpreted. You can, whenever you look at a graph, it is easy for you with all of these. Let's say it might be a pie chart, it might be a bar graph, it might be a histogram, etc. Okay, it's interesting. This is one of the interesting thing in SPSS because it shows us these graphical representations of our data. So let's dive deep into this topic. So we have a pie chart for time series. Why bar graph? Because we're gonna see the bar graph now. It's the list of bars because time series data, it's recorded all over time. It's easier for us to read the bars to see how the time has evolved for our data. And line chart for cross-sectional data, because line chart, it shows cross-sectional data which is not related to any time series one. So let's start following the steps on the SPSS. So to sketch a line bar or chart or line chart, we have to follow the steps below. So go to graphs, legacy dialog, bar, or line. Okay, so you can see here graphs. Okay, so graphs, legacy dialogs, bar, or line. Let's go do this on SPSS. Okay, again, graphs, legacy dialog. We can choose any type of data representation graph. Look, it might be bar, 3D bar, line, area, pie chart. Pie chart, by the way, is very interesting to show our data. Box plot, population pyramid, if we're talking, if data includes a statistical survey about population, scatter or dot, it shows our data plotted in a scatter diagram. Histogram, you basically know the difference between histogram and bar graph. So it's the difference is that the might talk to each other or a little bit far from each other. We're gonna see all of these. So you might choose all of these data, but for simplification, basically, we're going to be using a bar chart for time series and line chart for cross-sectional data. So let's go for the bar chart here because we have a time series. So let me go for the bar chart because our data, you can see here, see, it's time series. I'm talking about the GDP growth, unemployment rate male and unemployment rate for female across a time series from 2009 till 2014 or 1998 till 2014. So again, graphs, legacy, and let me click on the bar. Okay, here we have to choose the type of the bar. Let's make it simple. I'm gonna click on the simple and define. So let's start doing the GDP annual growth, for instance. So here you can see, you choose simple and click for the values of individual cases. It's basically a default. So I need to choose what does the bar represent and what does the variable I need to work about. See, here I chose the GDP growth and here I chose the unemployment with secondary. So let's go back. Let me just cancel it and do it again just to see if the okay, values of individual cases, it should be by default unless you've changed it into summary. So it's usually values of individual cases by default on SPSS and then click define. So I'm gonna choose here GDP growth and click this. So each bar represents the GDP growth annual term. And the variable here is, let's say, the unemployment with secondary female. So I'm talking here about the percentage of unemployed females. See? So this is mentioned here, the GDP growth and unemployment. So basically the bars represent the dependent variable, which is the GDP. and the variable will also see or represent the independent variable. You know the difference between dependent and independent? Each and every graph, x-axis and y-axis, always represent the dependent and independent variable. There are always dependent and independent variables. Here, the dependent variable is the GDP, because it depends. The GDP depends on the unemployment percentage. See, even if you're doing another research statistics, you will be able to choose which variable is dependent and which variable is independent. So we came here, and then the bar graph should be created. So bars and variable are located. So you just give orders to the SPSS. What do you want to represent on the bar graph? And then click OK. Okay. There you go. There you go. We've just created the bar graph. Here we have the value GDP growth, the annual percentage. And here we have the unemployment to secondary education female, I mean the percentage of female unemployment. And you can see the bars, they are not attached with each other. They are far away from each other. That's because it's a bar graph, not a histogram. Remember, I'm gonna do another histogram, and I'm gonna do several graphs for these two variables. So here we locate the dependent variable on the y-axis, and we have the independent variable on the x-axis. And just what I did is that I gave the SPSS information about what is the dependent variable, the GDP, and what is the independent variable, the percentage of female unemployment. And already I've previously inserted the data for the GDP and female unemployment, and the bar graph is created. Okay, so by the way, you can open here any, let's say a new folder. Let me create a new Microsoft Word document and open it. And then go and copy paste all of this data created here in the output, because you might need it outside the SPSS. So I can do this, copy and go to the new Microsoft and paste it. See, because you will definitely need this. You will definitely need to take away your data from the SPSS, because you might need it on, let's say, on presenting any type of data, maybe on social media, maybe for your lecturing your students, maybe on Microsoft Word for special purposes, etc. So all of these data presented here, not only the graphs, all of these all of this data presented in output can be copy pasted to a Microsoft Word. We can do the same thing for the summary report. Copy and go for the Microsoft Word and paste it, Control V. See, that's the table. Okay, so you can do everything. You can do everything. This is the thing that facilitates the work on us for the SPSS. So I'm not gonna save this, because it's can be done very easy. So this is the bar graph. So let's go and do other types of data. Here in the they just mentioned the here the bar graph. The same is done for the line graph. Okay, so let's go. Let me try to do another type of graph. So let's do histogram. Again, GDP growth, unemployment with female. Let me know if I've created. I guess I have created the bar. Okay, so see, this is by default. So simple, define. I will add the GDP growth, unemployment, and press OK. Okay, and this is chose again a bar graph. Let's analyze it for other things. Let's do it for the histogram. GDP growth, unemployment, press OK. Okay, here I've used, this is a little bit complicated form, but it's okay, you need to know this. Here I've used the frequency, the GDP growth annual, and the unemployment rates for females. This is a type of a graph where we have two y-axes and compared to one GDP annual growth. Further studies basically use this type of graph. We can also use something more, trying to do it more simpler. Let's try to do box plot, for instance. Simple summaries of separate variables and define. Again, GDP growth and unemployment with female. And okay. And this is the box plot. See? This is the box plot. I'm comparing the GDP annual with the unemployment rate of females. So you can see the values are stated here, and this is the GDP annual growth. You know, the type of the graph you choose is according to the type of your data. So for my data here, the perfect one goes for the bar graph, the perfect one, because I definitely need to plot how does the evolution of GDP growth go with my unemployment for female, and I can do the same thing for the unemployment of males. Okay, let's move forward into other topic. So let's go to part 5, the confidence interval. So to construct a confidence interval for the mean, we have to follow the below steps, which is analyze and then one sample t-test. I hope you're familiar with the confidence interval and the sample test because you will be able to use them. You need to basically use them in your SPSS. So basically here we have to click analyze, press on the, let me make it a little bit. So basically analyze, compare means, and go for the one sample t-test. And then we have to choose the variable that we're going to find and test the value should be 0. So let's apply this, compare means. See, compare means. Okay, we can do one sample t-test, independent sample t-test, bird sample t-test, and one-way ANOVA. The people who basically took a course about statistics will basically understand more than the others the things I'm doing here, but it's easy. You're gonna see the results on the SPSS output. So let me click one sample t-test. Okay, so here I have the variables. I'm gonna transform it into the test variables and press OK. Okay, so let's follow the steps. Here we can choose the variable that we are going to find its confidence interval. Again, we're going to by GDP, and the test value should be 0. So we're moving the GDP here, and the test value, make sure it is 0, and then go OK to change the confidence interval. So okay. Again, let's go to SPSS. I'm going to choose the GDP growth. Any other variable can be chosen. Double click or press this arrow and press test value is 0 and press OK. This output is created for us. Okay, so what does that mean? This is a t-test. You're basically most of you who already understood statistics or the basic level of statistics understand why do I need a t-test. So basically, T-tests include one sample statistics. We chose a one sample test. Here is the N, the mean, the standard deviation, and the standard error of the mean. You know, it's very important to measure the error because some data might include an error. So this is important to be clarified to be shown on the table. Here we have the T value, which is basically we need here the t-test. You know, on Google you can search, you can click the t-test, and you can see the values of the defined t-tests. Here we can see the DF, the degree of freedom. You can see the significance, if it is two-tailed or one-tailed, the mean difference, the lower and the upper confidence interval. All of these can be chosen. Let me go on. Let me go and show you the t-test table for those who are not very well knowledgeable about statistics, just to take an idea. Okay, so this is a sample of a t-test. I hope it is clear. Okay, this is a t-table. I'm trying to choose one that's clear for you. Okay, let me just make sure that you know what is a t-table, because you will definitely be using it. Okay, this is not working. Let me choose another t-table. This might work. It's not working. Okay. Okay. This is a t-table. Okay, this is a t-table. As you can see here, we have the degree of freedom, DF. It's from 1 till we have various numbers. Here we can see the values and the t-distribution critical values. So we have in t-table, we have two, t-distribution critical values and t-distribution calculated values. So it's not our main concern, but I'm just trying to introduce you what is a t-table, because I'm just explaining it. So this is a t-table. These are the values. So whenever you try to solve any statistical complicated issue, you will have to refer to the t-distribution. Okay, and here are the confidence interval levels. I hope you can see them. You can just put on Google for any further information and see the t-table. You can see any type of all of these t-table, and are easy to access. Okay, this is much easier. See the distribution. This is the Z table. It's not our major concern, but it's similar to the T table. Okay, so I'm gonna go back to my topic, but you basically need to understand what is the meaning of these values. Okay, so these values, these are created and interpreted using my SPSS, or I ordered the SPSS to create a one sample t-test. Okay. Okay. Again, let's go into the PDF, and it's here. Okay, so that's how we created the t-test table. As you can see, it's the same as the result we had. And when I talk about the confidence interval, you can see here the confidence interval, it is written between 0.691 and 2.389. You can see here the confidence interval is between 0.691 and 2.389. Okay, it is you need to analyze what is the result of the confidence interval. In our case, the confidence interval is between 0.69 and 2.39. These are the lower and upper limits of the confidence interval. Okay. Let's do the hypothesis testing. You're probably familiar with the hypothesis testing. You're familiar basically with and H1 with null and alternative hypothesis. So we basically do them by calculation. Now let's start to follow the steps. Analyze the one-step t-test. So here we're doing analyze a compare mean one-step t-test. And let's go for a test value of 1.5. Previously, we added here 0. Now we will be doing it 1.5. We're just practicing different. So analyze, compare means, one sample t-test. And here it's still the same GDP growth, and I'm gonna here put 1.5. Okay. And the result is changed here. See, the test value is 1.5. Previously, it was 0. Here, it was 0. Here, it was 1.5. So definitely, the values are changed. The degree of freedom is still the same, but the t-value, you can just try to compare significant two tails is 0.92. So we have changed the test value for basically it's randomly a test value. And when I'm talking about 1.5 as a test value, I mean H0, mu is equal to 1.5 at level of 95% confidence interval. This is what we have done here. And the results are here as well. Okay, so what does the result mean? Okay, so we have a rule basically in statistics that says we have to check the significant tail. This value is what we need. This value is what we need. So the p-value is compared with alpha. So whenever the p-value is less than alpha, we reject the hypothesis. When p-value is greater than alpha, we do not reject the hypothesis. Well, this is the main rule we're following here. In our case, 100 minus 95% is the alpha. How do we calculate the alpha? We have 95% confidence interval. The overall is 100%. So we deduct 95 minus 100, it is 0.05. So our p-value is 0.922, which is greater than the 0.05 calculated. So the result is we do not reject H0. See how do we came into the numbers? I'm gonna repeat it again. So basically here, the rule if the p-value here is greater or less than alpha. How do we get alpha? Alpha is a term that in which we deduct the 100% minus the number of the percentage of the confidence interval. It's 95% here. So the final value is 0.05. We compare this number to the 0.05. If it is greater, then we do not reject the H0. Okay, so that's why we need in SPSS to have this table. We need to have this table just to verify if the hypothesis of our research is rejected or not rejected. Okay, so that's how we when we defend our research, let's say we're doing some advanced research or we're gonna defend our research, we have to be relying on these numbers and these tables. Again, this is the result obtained. Okay, now we came into part 7, the correlation. Okay. So we basically, both of you know the meaning of the correlation. Correlation is very important to know the relation between the variables. The correlation, I'm gonna explain it now whenever I give examples. So correlation is a very important type to be addressing, a very important topic to be addressing in the SPSS. So we'll start to correlate see what is correlation, its types and everything. So let's go to our SPSS, press analyze, correlate, and go to the by value. Analyze, correlate, by value. Okay, so let me first explain for you. Okay. Minute. Okay. I have prepared for you some of the SPSS manual data manipulation. Okay, let me just explain for you this correlation part before going into. Okay, so what do I mean by correlation? So basically we have in statistics, we have univariate and bivariate statistics in SPSS. What do I mean by univariate and bivariate statistics? Univariate statistics summarizes only one variable at a time. So from its name, univariate, it summarizes only one variable at a time. However, bivariate, so the word here, bivariate statistics compares two variables. So I need just to explain the bivariate and univariate before implementing it on SPSS. So we also have in statistics multivariate statistics that compare more than two variables. So in sequence, they are univariate, bivariate, and multivariate statistics. So the univariate analysis basically is a simple and fundamental type of statistical data analysis where only one variable is used. There is no relationship between a cause and an effect in this data because there is just one variable. So it is mostly used to describe data. So I talk about univariate analysis when I describe data. However, coming into when I talk about univariate, I will select all areas such as mean, median, standard deviation, etc. Bivariate analysis is one of the statistical analysis where two variables are observed. So one variable here is dependent while the other is independent. And these variables are usually denoted by X and Y, whatever you can name your variables. So here we analyze the changes occurred between these two variables and to what extent is these or does these changes occur. So to do this analysis, I'm gonna go and see how to do a bivariate analysis. Let's go again, analyze, correlate, and bivariate. So analyze, correlate, and bivariate. So what do I need here to know? I can just add any two variables. I need to determine what's my dependent and independent variable. So here I introduced all of these variables, and here we can among them. Let's do it step by step. So let me introduce the variables here and see how they are correlated. So you will be able to understand the concept of correlation. All right, so you can see the table here under the name of correlation. A very important thing is that here we have the variables GDP, female unemployment, and male unemployment. Here we also have the same variables, GDP, unemployment female, unemployment male. So I'm just seeing how the variables are correlated to each other. See the concept of correlation? As you can see, the correlation between the GDP growth and itself is 1. The correlation between the female unemployment and female unemployment is 1. The correlation between male unemployment and male unemployment is 1. So the correlation range between 0 as the lowest value and 1 as the highest value. So a value was, what's the relation between you and yourself? It's very high relation. You're highly correlated self. So it is 1. However, always we can see 1 numbers listed on the table as the values are correlated to themselves. Okay, so let's do the other part. What's the correlation between female unemployment and GDP growth? GDP growth and female unemployment. It is 0.591 in negative. See the negative value. Now, what does the negative value mean? So it is 0.51. Okay, so let's go to the output here again. So the correlation between the GDP growth and unemployment of female is 0.59. It is negative, but it's in the middle. It's negative, but it's in the middle, 0.5. It's between 0 and 1. The same thing applies for, look, I'm reading Pearson correlation. See, the same thing applies between male unemployment and GDP growth. Okay, let's talk about another values, the GDP annual growth and the unemployment with education of female, 0.5. Here it's 1, obviously, and here 0.9. This means that there's a high correlation between the male unemployment and the female unemployment. Is 0.9, almost 1. This number is interpreted as high positive correlation. However, this number is interpreted as middle because it's 0.5, middle negative correlation. Okay, so let's come into this number, 0.5. It's the correlation between GDP annual and male unemployment. It's negative middle correlation, average correlation. 0.9 is high. And this is logic, by the way. The female unemployment is highly correlated to the male unemployment, 0.9. This is logic. And here the number is 1, as we can interpret as well. Okay, so you can see that the table of correlation shows us how the variables are correlated to each other. And if you want to talk more details about this part, I've created here for you here is the correlations. You can see, you can read them here, Pearson correlation, as we have just did. And here is the range that we use in order to evaluate the correlation, that is also called Pearson correlation. What does that mean? This is the range. You can see if the number on the Pearson table here, if these numbers are negatively but close to 1, let's say minus 0.8, minus 0.9, minus 0.7, this will be strong negative correlation. So you will ask me, what's the relation between these two variables? The SPSS shows that it is a strong negative correlation. If the number is around 0.5, but it's still in the negative, as here, see, the relation between female unemployment and GDP growth is minus 0.59. So it's located here on this range. So we can say that the relation between the GDP growth and female unemployment is weak negative correlation. So this is the negative part and this is the positive part. Coming into the positive part, if it is 0.1, 0.2, 0.3, etc., it's weak positive correlation between variables. If it is okay, so here I should have excluded the 1 here into the range. So if it is 0.5 and above, it is a strong positive, and 1, it is the biggest correlation ever. Okay, and again, if the number is 0, this must be expanded forward. If the number is 0, that there is no correlation. There is no correlation. It is neither strong, neither weak, neither positive, neither negative. 0 means no correlation. So, and the correlation is represented in statistics by the letter R. as you can see. So, you know, it's not just only in, okay, so here the moderate, okay, here's the completion of the graph, moderate, no correlation, and moderate. These are for the no correlation for the zero. This is for the negative part, and this is for the positive part. So you can see it's not just only important to extract outputs from the SPSS. It's important to interpret these outputs, to understand what do these values mean. So I did these steps. I pressed on analyze. I extracted these reports. I extracted these graphs. I extracted these tables, these classifications, etc. But when I come to the output, what does that mean? What do these numbers mean? So these numbers basically mean that I need to analyze and interpret each and every part of my data correlation, data linked variables, linked aspects, etc. Okay. Let's move into, so here again, the relation between GDP and unemployment is minus 0.591. Since it is minus 0.59 rounded to the minus 0.6, okay, it started with the strong correlation. So we called it a strong correlation, and it is a negative. So because it's in the negative, so it is, when I say interpret the value, what does R mean? You can tell me it is a strong negative correlation because it's around 0.6. Okay, great. And do the same thing for the others, by the way. If R is 1, it is the perfectly correlated. When R is 1, here, we have 3 values of perfectly correlated because GDP growth is perfectly correlated to itself. So the values are 1. The same for female unemployment, the same for male unemployment. Hope this clarifies the thing.